we're going to talk about resource management, apparently. So, resource management is basically handling of external resources. Um, so, as an example, like opening a file, when you get when you open a file, you better close it. It says you always want to return an acceptable state without leaking memory or file handles, for example. So, that makes perfect sense. So, I think we're going to learn about the idioms in Haskell to make this happen. So there's something called the Brackett Idiom. Basically, there's three states: acquisition, use, and release. Since these resources are external, in the world of functional programming, we can represent each of these phases as a function. Da, 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 da. Okay, so we get a type signature that looks like this from a function called bracket. So IRR IO unit, and then so this is like choir. Probably don't need that many spaces. Use. Well, it's the other way. It's release. Use. R to IOA, R to IOB, IOR. So B is probably void in a lot of cases. What's up, Baji? How's it going? How's your day? You ready for some Haskell action? I certainly am. Plus, I have a bunch of announcements today, but I'm going to do those later, so you're going to have to hold your horses for those. But they're coming. I don't know if they're not big announcements or anything, but they're announcements. All right, so anyway, we basically are going to write, let's just write bracket acquire function, a release function, and a $sign R2 da da da. All right, so something like this. Maybe there's a do here. Okay. Given the acquisition and release take relatively little code, this puts the focus on the use part. Excuse me. It's talking here about other languages that include exceptions, which I assume we're going to talk about here in a little bit. But what is this? Use Haskell. Oh, maybe. Use. Not sure exactly what that means right now, but that's fine. We'll get there in a second. All right, so there's a specific version of this bracket function for files. So file path, which I'm pretty sure is just a synonym for string, or an alias is the proper term. Some IO mode, and then handle IOR IO. So I guess this, well, this is abstracting away the grabbing of the handle, right? Oh, I see. They're providing the implementation on the next line. So it's like file path mode equals bracket open file fp mode h close. Yeah, so open file returns a new handle, and this closes it, and then this is supposed to return an IO of R. Oh, right. This is a partially applied function. I'm waiting for this function. Right. So we've created a function of this type. So we're just waiting for the new one. There's something to do with the handle. Yeah. It says apparently there's another one of these for with temp file. I think Jappy was using that earlier actually. So behind the scenes he was using these. So it says nicer code with continuations. I think what's up, Jappy? It's not horrible. It's just code. It's all just code. Yeah, they're talking in the book about with temp file basically, which I think you were using earlier. But apparently it's like using this bracket function behind the scenes. Although I don't know if that's actually true. We can go look. Beauty of Hoogle. With temp file. Actually, you were using temp directory, weren't you? Technically. Yep, there it is. MC Brackett. Man. Oof. That'd be a pretty good MC name. MC Brackett. Probably already exists. Oh, no, apparently not. Just a bracket for a wall. Wonderful. MC Brackett. Gonna be my new MC name. Okay, anyway, Motor Club. Oh, sure. Motorcycle Club, I got you. We can start our own Sons of Anarchy or something. Okay, so next set of code, which is terrible. We could write something along these lines. I think the point is that it'll be better later. Out file, write mode, out handle, do something. All right, so this I think is what is referred to as callback hell. Is that right? Whoops. What was I talking about? Like an MC, a rapper. Actually, I don't even remember what MC stands for. MC acronym hip hop maybe? Master of Ceremonies, that's right. Yeah. That's what I was talking about. All right. Apparently, there's something called the managed monad, which can do this for you. We can try and get it real quick. I don't need to do that. I must channel my inner Lumi. I upgraded my stack today, so hopefully that doesn't cause any issues. I shouldn't have to build much. I already built HIE, so like that's the thing that takes the long time. And actually, it's not that long when you have 16 cores. So, you know, if you want to use HIE and update stack before you start streaming, make sure you have 16 cores. Although I'm not even sure that I needed to rebuild HIE, to be fair. Okay, so now we should be able to get this. Where does this come from? There's nothing in the book about this. We'll Google it. Run. Yeah, I still don't know Nix, unfortunately. That's definitely something I'd like to do. Control monad managed. So we could write import control monad. Yeah, when you were saying, when we were talking earlier about working on that audio video processing thing together, I was like, oh gosh, I'm gonna have to figure out how Nix works if I want to help. I do want to work on that. I think it's interesting. Okay, so we're gonna write a do work function, which is just gonna be undefined for now. Then we're gonna write a process. Yeah, that's fair. I mean, it's mostly just me writing like what Nix build -a something or another. Unsuccessfully. That's unfortunate. If you have questions about that stuff, Jappy might be willing to help you out. He's pretty good with that stuff. And if he's not, you know, I'm not volunteering him to help you, just for reference. Okay, so we have that, and then we need to lift into IO, do work, in handle, out. Yeah, I think the Nick. Are you reading the Nix pills thing? My understanding is that's like the thing you need to read. Yeah. We should be able to get these automatically. I just need module system IO probably. So 9. Fair enough. It seems like it's not the most beginner friendly piece of software in the world right now, but it does seem like it's solving a real important problem. Oh yeah, yeah. We have actually a video. If you're interested in, you know, messing around with this particular setup, you can. The hardest part about, or like the most time-consuming thing, is just installing HIE itself. Once you have stack and stuff working, then it's pretty easy. But yeah. I think in the YouTube video is probably a little old at this point, but you know, it's got most of the ideas there. It's really nice. I mean, like, there's, you know, formatting right in there. Not that that changed much, but we can do formatting directly in here. We get autocomplete, and we get like definitions. So if I want to see, you know, what with file is, it's all in here, which is nice. I've been pretty happy with this. So Intero, somebody was talking about Intero today. You have to install Intero into your project, right? Like, they were talking about GHC IDE, I think, and Intero. Well, it was separate. Intero was separate from that. But it looks to me like you need to install Intero as a dependency on your project. Is that incorrect? Well, I guess it doesn't need to be in your package YAML, but you still need to write stack install Intero or whatever it is. I don't fully understand all the details, so don't pretend like I know what I'm talking about. That would be a very dangerous thing to do. All right, so this is managed. I guess this is just continuations. Yeah, so it's the general concept of a continuation. The core idea is whenever we talk about a value of type A, we could also express it as a function of type. So continuations. Let's see. When oh, okay. Yeah, I think that the person who authored the blog post that I was reading had something about copy compiler tool, but install it per G version. Okay. It does look useful, so I don't fully understand how it integrates in, you know, the editor, but it does sound useful. Like being able to open up a GHCI window or whatever, I'm not sure what the right terms are here, and just kind of work on your project from where you were sitting. That seems pretty useful. When talking about a type A, I think it's solving a different problem, right? HIE is doing the sort of the LSP editor functionality, but GHC does some, or Intero seems to be like it's sitting next to and still doing GHCI, and you can open up that GHCI and run code from it. So like if if we were just saving, we would type some key command and then do, we would just be in GHCI. We wouldn't have to like close and do stack GHCI or whatever and then work from here. It would just like work from wherever I was. Am I misunderstanding that, or is that what it is? So, Aji, I think that there's a recent change to HIE in the last like 6 months that fixed some of the memory leak issues, because we use it for, well, actually I do close and open my editor quite often. Not on purpose. I'm trying to be better about that, but I haven't noticed any crazy memory problems, and I haven't noticed any obvious memory leaks. There may be subtle ones that I'm not seeing, but there's no obvious ones. The first time I used HIE, it crashed my computer multiple times. So, it's a lot. It hasn't done that at all. And we were using at one point this simple GHCI plugin for Atom, VS Code, and that started crashing my computer as well. So it's like I've had, yes, it crashes this computer, and this computer is quite powerful. Um, it happened multiple times. Like it took down the stream and I had to restart from, like hard shut off the machine. Yeah. You basically can't leave it open, or you weren't able to leave it open for a long period of time. And what we were doing it in VS Code the first time. Yeah, basically. Uh Doing a lot of talking. You guys are effectively distracting me. We could express it as a function. Is it R to A? A to R to R. So if I remember correctly, I had a lot of trouble with this at the beginning. So I'm yeah, chat wins for sure. I really did not have a good understanding of how continuations work. Um, yeah, I'm excited as well. I didn't understand this before. So hopefully we learned something. This is kind of the part in the book where we wanted to get to. Like everything before it, we kind of knew. This is the new stuff that, well, it's not new. I've seen it before. It's just, helping me. Anyway. Okay. So whenever we're talking about a type A, we could express it as a function A to R to R. The reason is that having the value is equivalent to having a way to apply any possible function you want over that value. We often say that the function A to R in the signature above is a continuation that consumes a value of A. So we have a function that consumes a value of A to create an R. That's the continuation. Consumption. I like the term consumption. I'm going to write that down. Consumes A to generate R. Additional A to R is representative of applying any function. I don't know how to say this right. A to R is representative of applying it's having a function that maps over A, because that's basically what it's doing. Well, it's not mapping over A, that's not correct. That can be applied to A. Type A. Yeah, I think that's fine. I'm trying not to like rewrite exactly what's in the book, but say it in my own words. And, hopefully that helps me understand it. I think that's a common thing for people. It says the entire type above is usually represented as cont RA. So it says, I don't understand. Just give me 1 second here. I should be alive again at least. Yeah, my VPN just dropped completely and I can't pick a new server or anything. So I'm trying to see if it's just dead right now anyway. It might just be broken at the moment, but it seems like it should be fine. None of these are... The servers appear to be up. Definitely seems like they're getting hit hard, but I don't know what's going on. I'll just have to be careful not to... well, my IP address. I always attach a VPN just in case my IP leaks. But, well, you know, apparently that's a thing that people do. Is they DDoS your wireless, or I'm sorry, your internet. So like some of the big streamers, for example, I'm not a big streamer, so it shouldn't affect me at all. But some of the big streamers actually have 2 internets, so that they can be on a VPN in one, and if they start getting DDoSed, they can switch their VPN, and then if that doesn't work and they figure out their IP, they can switch internets. So it's like, so I'm just trying to protect myself if I can. Yeah, it's like crazy. Like paying for 2 internets is pretty wild. I'm just gonna make sure that we don't start dropping frames like crazy all of a sudden. Just give it a few minutes. Or, well, I'm not gonna sit here for a few minutes. Let's start. Let's see if we can keep going. Okay, so what we were doing before that failed is trying to find the... I want to work with a custom one because I don't want to use the monad transformer if I don't have to. Yeah, that's true. I don't make my income off of it, but I also don't feel like having my internet DDoSed. So we're streaming off my, well, yeah, I mean we're streaming off my regular IP right now, so we'll see what happens. But it did die. I mean, I'll have to ask about that. Okay, so we're just gonna create a new type here, called cont, which is going to be cont a to r. Yeah, like if they have internet problems, then they're literally losing, like they can't work. So, you know, we need internet to work as well, but we're not streaming to 1 million people. We can go to a coffee shop or something. What is this for all for? On this cont thing. Oh, sorry, I said on. Oh, this cont thing can make set a behave like a functor, I hear. I guess we'll find out. Set behave like a functor. Interesting. Oh, right. Oh, okay, so the for all is necessary because R is determined by the caller of toCont, right? So I can't determine the type of R because I'm going to create like some arbitrary R. So it's determined by the caller, hence the for all. So we clearly need a constructor And we need to generate a function that creates an R. So and then this is going to require, yeah, this. All right, easy enough. So this is going to be for all R, con RA. I have a function f and I need to get an A out of it. I have an A to R to R. So if I want, how do I get an A out of that? If I apply F, oh my god. So this, why does this hurt my head? This shouldn't be this hard. This takes a function. This represents a function that can convert an A to an R. You don't have to convert A to an R. You can convert A to an A. You give it this function to create something new. For whatever reason, this really hurts my head, and I don't know why. It shouldn't be that hard. And I think the last time I wrote this, I know I've written this exact thing before. I sat here probably for another 10 minutes, and this just did not sink in for whatever reason. This is one of those things I feel like I need to practice. So I think when, okay, so let me try to explain my confusion. For some reason, when I look at this f, I think that it contains a function, right? Like this is somehow contained within the f. But that's not really the way to think about it, right? You have to think about it like the way they told us, is that this function represents a way to turn an A into an R, right? So if I want to take an A and convert it to an A, I just apply id. And that is just A to A to A. It's just like, it's not that complicated, but for some reason it just doesn't work in my noggin. Okay. It says continuations may look alien at first glance. I don't think it's that hard. It's tricky. It it is hard. I don't know. It is hard. I'm not going to back off of that. I think it's difficult. Or I personally find it difficult. Yeah. I mean, but it's not. It's not a couple minutes. I feel like I've done this multiple times and I'm having trouble still. All right. So do 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 do. Okay. So basically, it's pointing out about, or it's just discussing callback hell. So in right in just as an example, if we did something like the following. I think I've sort of already said this. Right. This is essentially the callback hell. Because you just have like this repeated structure over and over and over again. And then when you add a new one, right, you just essentially become infinitely nested. In Haskell, however, we have the niceties that the that continuation is a monad. So we can literally just write the following. And so on. So that helps us out a little bit. Anytime we want to add a new action, it's not just infinitely nested. You just add a new action and life. Okay, so now I think what we should do is write the monad instances for this, and I think there's some notes about how to do um, towers. We make those towers. I don't know what that means. Oh, these towers. You just infinitely nest because you don't have monads. Doesn't sound very fun. Oh, I'm sure they get really, really big. Okay, so let's see if we can implement monad for this. So we need instance. I've probably done this a bunch of times as well. Functor cont r where why am I writing these weird things all of a sudden? Let's just get all the structure done and then we'll start implementing. Well, they have a less general variant of monad called a promise. Oh, right. I actually have heard of that, I think. I've never used it, but only because I've never really written JavaScript. Only to hack other things. We need applicative, which needs to be pure. A find and then got to be the same, so we'll just leave it like that. And then we got um okay, so that's the scaffolding, and then now I need to write these things. So R represents so we need to build a new continuation and need to convert A to a B. We have a R takes a function. What's up, Captain and Johnny? How's it going? I am doing well. We're running Haskell, so I'm as happy as I can be. And we did lose the stream for a little bit, but we're back now. Our bit rate is doing okay, so that's good. How's everything with you? So, right. We need a B. And then B. So if we apply, oh wait, it would be like stop writing just random stuff. Think. Sure. Um, nice. 200 pages already. Wow. That's impressive. This is like uh basically a quarter of the book, right? Well, no. A little less than that. It's like a fifth of the book. I can only write random stuff and make it work. Yeah, I'm trying to think about this carefully. We need to create a B to R function. And how do I do that with an A to R function? It just R. That's what I wrote before, isn't it? It's one of these. I'm pretty sure it's just like either this or this. It's not, so that's good. Why can't I do this? Hmm. Functions are mappable, yeah? Well, that's just composition. So that's not going to work. Well, I don't know what I'm doing. Right, so the type of this, oops, wrong button, is B to R to R. I need a function that can convert a B to an R and return an R. Can take a B to R function. What does that help? Does that help me? So R can take an A to R, just RF, isn't it? That's the same thing. That's the same thing that I had before. So like brain doesn't work. So what's the type of this? I think we should just open up. No. HCID stack. What now? There we go. It's like, what? I mean, I don't know what's allowed, but it seems to me like if I apply R to F, I basically get a B. If I have a B, I'm not even sure. So if, okay, let's, yeah, I don't have a clue. I don't think you need contramap though. Like if my if I recall correctly, I don't need contramap, but I don't know exactly what I need. So if I'm thinking about this correctly, this gives me a B, right? And what I need is a function that I just need to apply this to a function that has the right shape. So why don't I just create one? So if we have like RB, so this returns a B, and I need a, what's the type here? Well, that doesn't help. I don't know what I'm doing. I'm gonna look it up because I'm tired. I'm gonna be able to like look at it and just be like, oh yeah, of course. Makes perfect sense. So we're pulling apart this M. We shouldn't need the run const T. So how is this different? That's true, but the only difference between the monad, the transformer is that this M is identity, right? So it should really just be, oh well, it's a little different than that, I guess. It's just, okay, so then it's R C dot F. That's the right answer. Sorry, I just had to do the translation in my head. So C has to be a function from B to R, yeah? Yeah. I don't know why it's called C, but probably continuation. We actually knew that. We knew that that needed to be a B to an R. Well, sort of. So if we have F is an A to a B and a B to an R, then we can convert an A to a B. Is this contramap? Might be. Let's look contramap. I forget as well. Oh, right. I'd have to look up instances of contramap. I'm not going to look this up. So okay. This is hard. So that one's easy. All right, this one we're gonna need to oops. So this is going to be right. I think I had those parentheses correct. But we should use different. Oh no, that's right. And then this will be ARR and we're gonna need some sort of continuation again, I think. So our continuation function again has to be B to R. Oop. That's R. This if I did C dot R again, Is it just the same thing? Oops. I wonder if it's the exact same thing. I don't think it is, but I'm willing to try it. So what's the type here? Oh, well, that's not gonna help. Let's go over here. Yeah, it can't be the same. That's not possible. Wrong button. Can't be the same. So what can I do with C? I probably need to... What do I get if I F map C and far? Hmm, doesn't really help me at all. Yeah. Ugh, this is just not clicking right now. It's not even close to clicking. I don't know. Just don't know. I need to embed it twice? My goodness. So... No. No, I don't. Yes, I do. I mean, I just don't know what I'm doing. That's the trick. Like, I'm feeling very stupid right now. Um, I thought I figured this out before, but clearly I haven't. All right, so we need a G V. This looks like just F map C. So CF map CF map V. So it's far Isn't that right? I can't do types today. I guess I can't do Haskell today. I don't know why. So it's like FM. I have. Oh no, that's different. That's clearly different. So we needed to apply far to G2 R. All right, we gotta think about this really, really carefully. I think this is one I wrote down that I need to like practice often. So let's look at the types here. I mean, I can figure it out from this, but like that's not the same as figuring it out for myself. So what's G? G is an A to B. And is C in fact a B to R? It should be. Yeah. I don't need these parentheses. The resultant type should be B to R to R. Yep. Okay. So G is an A to B. Why do I need this A to B function? I see. Right. Because I'm waiting for this. This function doesn't exist. That's the thing. Or, well, I'm saying I can take this function and convert it to an R via some kind of function like this. That's a very weird thing to say, but okay. So then we have an A to R to R, an A to B, which we're extracting from here, a C, which is a B to an R, so one second. Okay. So this here gives me, wait, what does this give me? B to B? Shouldn't this be A to B, then B to R? No, it's B to R. Sorry, A to R. Gosh. It has to be an A to an R. So we build an A to R, we get an R. We build an A to R. I can't do this right now. Let me see if like following the logic in the book will help me understand what's going on right here. I can't do it right now. I'm feeling very stupid. If somebody has any intuition about how this works, I would love to hear it, but I cannot come up with the intuition. Right? I see this as being, this is a function from A to R. Oh, but it's not evaluated yet. This function doesn't exist yet. So we're saying, if we could build this function and apply it to this, I could give you an R. So the type of this, the problem, I can't get the type of this, can I? Is that just everything after this? Yes. All right, so the, no, not G. This generates an A to B to R. Yeah, that actually would probably help. It's just tricky. You just have to figure out where to put your cursor sometimes. Like if I put on the $sign, then it's bad. Well, hard to read. But like the type of this whole mamma jamma here is A to B to R, which makes some sense. Kind of. Wouldn't say a lot. It makes perfect sense. Okay, I'm gonna go with my original intuition and say, let me read the definitions here and see if that helps us understand what's going on here. Yeah, then it fits. Yeah, then it's this function, right? You need to create this function. That's the that yeah, that's what we're doing. We need to create this function so we can apply far to it. But no, the intuition is clear. Maybe what we'll do is what we could do, and actually I read about this recently, is we could say like, let's open up a new file and do this again without looking back and seeing if we can reproduce what we did without, like, I mean, I could just copy and paste, but like try and talk it out and say like, these are these things and let's do this. Do it a bunch of times. We could do it 3 times, 4 times. I don't really care. But let's finish the whole thing and see if we can. Again, I want to see if there's more intuition to be had. Hang on. Okay, so the return. Well, we know the return operation because it's just pure. We already wrote it. It's easy. For bind, the best approach is to expand the definition of cont r in the type that function ought to have for the corresponding instance. All right, so let's start writing some types. So R is F is, I just realized I can write this a little more compactly this way. Saves a little tiny bit, but, and then this is going to be an A to cont RB, and is going to be cont RB. Well, I should write it in the other syntax. Like, I know this is technically not correct, but it might help me think about it. Just put this in parentheses. It's not beautiful. Just leave it like that. So this one, I think you need the run continuation to make this work. So all right, so C is a B to R. So we're gonna apply C to F I wish I could like speak out loud while I'm thinking about this, so I apologize if that's really boring, but I can't. Oh, right, I'm supposed to read. That's the whole point. So, yeah, we have R, which is A to R to R. We have an A to B to R, right? That's this one. And we're supposed to get back a B to R. Okay. We know for sure that the result of applying the first two arguments is going to be a function that consumes the given continuation of type B to R. We know for sure the result of applying the first two arguments is going to be a function that consumes given continuation. The first two arguments? That doesn't. We know. Okay, so I'm gonna read this out loud one more time. We know for sure that the result of applying the first two arguments is going to be a function that consumes the given continuation of type B to R. Right, okay, so that's this C. A function that consumes. In this function, there are only two possibilities for obtaining a value of type R. Provide X with a continuation of type A to R, or to provide F with both a value A and a continuation B to R. Right. By the way, X is just R in my case. To provide R with a continuation of type A to R, or to provide F both a value A and a continuation B to R. Because the second option is not really possible, since there's no way to get our hands on a value of type A. So we have to write the following, apparently. So this has to be wrong button. An A. Okay. So if I have an A, I can apply F to A. And I could okay, that's not clearly not correct. So this produces a continuation. Oh. All right, so C is a B to R, and we have um, a, a function that consumes the continuation. The terminology here is, I think, what's really hurting me. So this consumes a continuation? Is that the way to say it? This piece? This is the continuation. So this consumes a continuation? Something like that, anyway. So it says the intuitive interpretation of this code is that it takes a function that expects a callback and a function that consumes this value, but creates another callback and creates a bigger box in which you only need to provide the second callback. It's not really helpful. I disagree with that. That's not intuitive. Sorry. All right, so here's what we're gonna do. We wrote this function. Now we're gonna write it again, and I didn't want to close that. We're gonna write it in a different function. Source. We need. What do we need? Just this. And we're gonna try and talk it out loud and see what we can do. So if I just put a random A in here, does this? Do I need to restart it? Good. Okay. So again, we'll create our stubs. We'll see if what we need to actually pattern match out. I'm not even 100% sure what needs to be pattern matched out. So we're gonna have all right. So yep. So we need a continuation. And I keep hitting the wrong button. So we have a B to R. We have an A to B. Right? It's B to R though, isn't it? Yeah. So I need to apply R. The only thing I can do is generate a function A to R, which is C dot F. So I need to consume a function A to R, and to generate that I need the continuation of B to R and this original function. Okay, we were able to do that last time, so that one wasn't very hard. So this is just and this one's going to be A to B to R and R. So aber sorry if this is boring, but like I need to understand this, so repetition is important here. I could probably talk about some other stuff as well. So we're gonna have to start here, undefined, and then C is B to R. All right, so I need to apply aber to this thing. So we know that we need aber, and we need to generate a function, or we need to consume this continuation. So we need some other function here, D. I did that again, I meant CD. So this, a simple monk. Thank you so much for the follow. Really appreciate that. Hope you're having a good day and you're interested in Haskell. We're doing some, I would say this is pretty complicated stuff right now, but doing my best to try and explain it. It's just really hard. So this D is an A to B. All right, so now I have an A to B and a B to R, and I need to create well, first I need to consume an A to R. So it's basically like the above, and I need to create an A to R. So C dot D. Right, so here's the pattern, right? The pattern is basically like, I need to consume a continuation. This function needs to consume this continuation. Or this callback. I keep saying continuation, but that's the callback itself. So the only way we can do that is by just calling it with something that can consume it. So that's what you do. And then you just keep going. So in this case, you need another function because you need to consume another continuation. And then that's why you need this R here. I guess. I don't know how to intuitively explain this. I don't feel like this is intuitive, but I think I see how the types are working out now. Like, you need two callbacks because you need to consume this one and this one. Or, well, you're nesting them, right? To consume this one, you need to get further in. You need to get this A to B function, basically. Does this kind of make sense? Does anyone feel like this is more intuitive, or there's a better way to explain this? I feel like my terminology is really, really bad right now, but if you have any ideas, I'm very much open to them. So this is actually different than what I had before. This is that. So here we have R, which is A to R to R. By the way, I think using these is a lot easier than writing these instances, so that's probably a good thing. I'm going to write it like I wrote it last time, which I know is a little weird, but it's helping me think about what is actually in here. All right, so basically, I need to continue. Wrong thing. I need a continuation. And we look, that types B to R. Okay. So, and the pattern is basically the same every time. We have an R that needs to consume. Well, maybe it's not the same every time, but. So we have a B to an R. And we need. Okay, so the point was that we can't really get an A. So we need to make one. Right? Something like this. I did it again. Yeah. Okay, and then if we make one, then we can apply FBRR to it. But this has the type R. No. This has a B to R, so we need to consume C. So we run cont this thing C. Okay, cool. So we did it a second time. I should just write at the top. This is simply implementing code from lib.hs second time for practice. Okay. this feels more, I feel more comfortable about this and this, I guess. But the intuition is still not there. So that was pretty tough stuff. So let me take a quick meteor. So imagine the following code. Well, let's following. Whoa. Nope. Commas. I don't know what this is just junk. Okay. NixOS stuff. Not something I can help with, but you guys are welcome to have your conversation and I won't bother you. All right, so this is a hypothetical function. It does not exist. So, or a hypothetical block from some do. So this is like bracket release, I think. This is like number of sub. Whoa. Pools. This is like, let's. Seconds until unused. I don't really know what that means, but okay. So, and this is like acquire. Then we can do something like the following. Or instead of this, we can do something like the following. Do connection managed with resource pool. Well, this is like, oop, this is in some hypothetical do block. All right. So sometimes this hypothetical code really annoys me, but hopefully this isn't so bad. I mean, it's pretty bad, I guess. I don't know what create pool means, or if that's like an actual function. Yeah, like it's in some sort of resource pool thing, and this is not the same function. Although maybe Postgres has a create pool. There's one in persistent. But this is like a config. I don't know what that means. So this is some hypothetical pool function. Maybe there's a Postgres connector that has this. Although it did say Esqueleto, but data pool is the one I want. Okay. Right, so we have acquire. So acquire is the connect thing. Action that destroys, that's the close. Throttles connections as well? That's insane. That seems very powerful. The number of stripes, subpools to maintain. Amount of time. I don't know what a nominal diff time is, but is it just a... Neat. So do you use this when you're making database connections, basically? Like all the time? I suppose you can use it for any sort of brackety type thing. Have you used it for anything else? There you go. SMTP. Got it. Wow. That's actually insane. Like this feels really powerful. This is a very powerful function. Well, library, I guess. Brian O'Sullivan. This looks really cool. Okay, neat. So just for reference, this is not explained in the book that this comes from here. So yeah, there's a lot of parameters. That's true. I don't really know like what the best choices would be for these sorts of things. Yeah, this is pretty wild. Wrong way. All right. So anyway, we make a pool, and then so if we what do I have to do here? What does this dot 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 mean? Am I supposed to do like would it be like this? Like I'm doing multiple queries like this, and then it just can reorder the computations because it knows about the different connections? Or am I doing this connection lift.io stuff in a different place? Like I'm going to pass my pool to a different function. What's the right way to think about this? Because to be fair, this is outside, by the way. So this is actually a separate do. And there's actually no do in the book here. So, whoops. It's just kind of like this. So it seems to me like you're creating a pool somewhere else and then connecting to said pool and doing your queries here. Although this dot 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 seems unnecessary. Yeah, I think that wouldn't make sense. I think the point is that like when you write this with resource pool, you're sort of getting a connection from the pool to use, and then you would be doing these sequentially, right? If we did these in order. Select from servers. I couldn't think of another word. Right, so these would happen sequentially as queries, but with the same resource from the pool. But we could have a simultaneous connection, do the exact same thing, but on a different thread, I guess. Like if this function was just separate. I think that makes sense. That's pretty cool. I think it's just like some arbitrary query function. I don't think that it's actually a real one. Um, but like, but yeah, I think something like this function. Yeah. What's Q? Oh, maybe that's the dot dot dot. This is what the result type is, I guess. To row. I don't know what this is. I think I really wanted this one. If we're using this as an example. Whoops. Because this is just a select. I guess it would technically be like this. You must be able to do some sort of I don't know, interpolation. I'm not really sure. It's not obvious by looking at this. Might be an example at the top here. Yeah, here it is. So this is the parameter substitution kind of stuff. Yeah. Eventually we'll do more databases and this kind of stuff will just be trivial, but we'll just leave it like this for clarity's sake. And then we'll write, you know, somewhere else get a resource and consume it, I think. And since this is like pseudo Haskell code in comments, we'll comment that. Okay. So that's resources, kind of. I mean, at a very high level. So the next part is about like releasing things early. So it says resource management with Brackett or managed guarantees acquired resources are released, even in the presence of exceptions. And it imposes a severe restriction on when release takes place, only after the whole computation is finished. That seems problematic. This means that we hold on to resources for too long, and those resources may be scarce. I guess database connections could be considered scarce depending on the traffic on your website. Well, if you had somebody connect to your database on your website and then it never disconnected, that would be a huge problem. So we're going to do a simplified example where we're going to zip a pair of files, apparently. Okay, so it says we're keeping the shortest file open longer than necessary. Okay, anyway, let's write this code and we'll see what it means. Although I think when I read this originally, it didn't really make that much sense to me, but this seems to make more sense now. Oops. Gosh. This looks terrible. But okay. Seems like there's probably an easier way to do this, but I certainly don't know what it is yet. So we're gonna take min1 read mode sign when you accidentally hit dot. Yeah, this already feels wrong. Shouldn't I be doing do? Chronoluminaire. How's it going? 3 full months. It says 4 months. 3-month streak. Either way, I appreciate it. How are you? I feel like it's been a while. Maybe you've been lurking and I just haven't seen you, but happy you're back around. Hope all is well. In one, into, out. Yeah, that happens. It's pretty tough to come and just watch things when you have a life and things to do, unfortunately. Oh my goodness. I think the point is that this code is like the worst version of the code, and we're gonna make it better over time. Or well, not over time, but so I apologize for this terrible looking code, but it's in the book, so I think that's the point. If EOF1 and into excuse me, into oh gosh, if EOF2 and in one out. H get char went off the deep end a bit. I have a RISC-V board. Been trying to write a bootloader kernel OS all in assembly. That's very impressive. Where'd you get the RISC-V board? RISC-V, I guess. Or which board did you get, I guess? One. H put char. Out. Then we're going to do the same thing with 2. And then we're going to go. Then we need to write end. Go in further. Oh gosh. Oops. Is that what's wrong with the link? Is there something wrong with the link? Interesting. Oh, that's fine. So you designed this yourself, or are there just like, oh, okay, so there's just built boards. Which one did you get? I51 Rev B. They're only $60. All right, so but this doesn't really. What do you do with this? There's just a getting started guide and an SDK, I guess. You know, I need to. I don't have time to get into hardware. Stop it, Chrono. You're trying to get me into more hobbies. You're a monster. I'm obviously kidding, by the way. That's not clear. And we have, so like, I've mentioned this to other people, I think, but I have access to like FPGAs and stuff. I really need to like learn how to use either Clash or something like that to try and write hardware. Can you use Clash to target RISC-V? Do you know? I certainly don't. I guess, and target a RISC-V processor. Wow. This seems like a lot of code to write this. I really hope that it will end up cleaning up. I mean, I think that first of all, we can use the manage thing to clean this up a tiny bit. And there's probably some way to clean this up. I just don't know what it is. So we'll see what happens. I guess there really isn't a way to clean this up. Well, we'll read. So, okay. Okay, so the point was here, just for reference, is we have this with file will appropriately close the file handles. The problem is that it won't close the file handles until we're done. So eventually we're going to short circuit like here or here, right? So the short circuiting means just that we've finished either one or two. So in this case, we've finished one, so we need to finish consuming two. In this case, we've finished with two, so we need to continue consuming one. So as we're running this end function, we're consuming one or two, but the other file handle is staying open for no reason. So now we're going to write a version which apparently will allow for release of the file handle early. So if you know, so that you can do that if you wanted to. Clash is for designing something like RISC-V. That could be true. Like you can you're designing circuits on the FPGA. That's a really good point, actually. I don't know enough about it to correct you, but that seems, or well, not correct you, that's not the right term, but agree with you or disagree with you, I guess. All right, so we got bin 1, bin 2, out. And then we're going to have a run resource T do. So we need rin to and route. Later, Jappy. Thanks for stopping by. I know it's super late for you. Appreciate the support. This seems like hard to deal with. All right, so in rin to out route do. Sorry, I'm kind of copying and pasting from the book right now, but I don't really see lift IO. H is EOF in 1. So if we're done with EOF 1, we release rin 1 to out route. All right. Seems fine. So it's basically like the same code here. So EOF2 into, if EOF2 then release rin 2 sequence end in 1 out route. Else go in 1. Wait, no, I gotta do something. Yeah, so do lift IO h get car in 1 find h put chart. This is probably behind my head. Hang on. Out. Let me. There's really not much I can do about it. It's so big. I'm gonna make the font just a tad smaller. Hopefully that's still readable, but I understand this code is getting a little hard to deal with. In 2 and then go in 1, rin 1, into rin 2. It's fun to say. I don't know why, but saying that in order is kind of enjoyable. Okay, so we also need to define end. So we're going to have end. Wait, we don't need. Don't we need the resource? Oh, okay. H close will just happen automatically. We only need to release early for the one we're letting go of. That's the point. Once we're done with this, it will just close because of H close. So we don't need the resource, or I don't. We'll go look up this allocate function here in a little bit just to decide what the correct term is here. Oh yes, I 100% should do that. Thank you. Easy to make those kinds of mistakes. So this is going to be out route, I guess. We're going to have basically this function again. Except we don't need to release, we just need to return this, I guess. Oh, wait, why do I need to? Why do I need to do that? Why do I need to release route? Shouldn't it just do that? If I return unit, shouldn't it just close both the other things? It seems like it should. Oh, I missed this code. All right, and then we need to go get the following functions. We probably want 4. How would it get allocate? Where's allocate from? Uh-oh. No, we're fine. Not dropping frames. I got concerned again because we were dropping frames earlier. Let's just hop out of here and deal with the build errors. We need transformers. That's not surprising. 24G. I don't. Oh, the error might have been at the top of the file. That's probably why it didn't work. It didn't look like there was an error anyway. Hopefully we don't need to rebuild transformers, but we might have to. What? Oh. It was searching for transformers. I don't actually need that. So something about this is incorrect, so let's go look that up. Run resource T. Oh, it comes from a package called resource T. I probably want to use that, I guess. That's, well, probably. So 25B resource T. And then my guess is that release is from there as well. And probably allocate as well. It's interesting. So one thing I don't understand is why I need to release here at all. Let's go back to the original code because it's easier to understand, I think. So up here, I don't release. I just return because it should be released for me, yeah? So why do I need to release here? Do I need to? Is it completely unnecessary? How can I tell if I have a dangling resource? Because I never release whatever the longer input is. It gets released automatically. Does that not happen for the output file? Or does it just leave the output file open for... Okay. Okay. I'm just... So because we're done, like we're done with our go function, and we eventually hit this return statement here, it should just close all these file handles for us because we're using this allocate function. Okay. As long as that's actually the case. I don't actually know how to check if I left a dangling file open. I'm sure there's a way to do it. I don't remember exactly how. Probably just look at the process table for, not the process table, the I don't want to think about it. I'll Google it later. Okay, so there are two packages available that provide early release functionality for resource management. Resource T via the resource monad, which is what we're using right now, and pipes safe via the safe monad. In this section, we exclusively focus on the former, which is right. Oh, right, because yeah, none of these are matter. Wait, do they matter? No. Yeah, they don't change. Do. Oh wait. Oh, thank you. Um, is this something fixable with scope type variables? No, that's type variables. That's not going to help me here. Um, oh, also this one. I I don't exactly know why that doesn't work. And yes. Um, there's probably some sort of scoping rule here that I don't remember. Oh, I need to update the subscriber goal as well. Fantastic. Um, I don't actually know why that doesn't work. Yeah, I think there is something weird about. Actually, I think it's because the where is considered outside of. Oh yeah, outside of the do block, exactly. Because the where is, uh, in uh in IO, we're in the wrong monad, right? So this stuff is happening. Wait, no, that's not right. That's not the right way to say it. Um, but yes, this one weird trick. But yeah, we're not operating in the same spot. This where is just attached to the, I don't know, the outer scope. I'm not sure what the right term is there. But these are inside this do block. Anyway. All right. Let's see. In this case, we get a release key in addition to the resource itself. We can work with this resource as we did with any of the previous approaches, and the monad ensures that the resource is released at the end of the block. In addition, we can call release with the previously obtained release key and force an early release. It is guaranteed that no resource is released more than once. In oh, you know what's funny is it does say in figure 9.2 they use resource T. I tend to write code and then find out that, they tell me exactly what I need to do, but I guess Googling around for it wasn't very hard. The allocation is similar to the uses of manage, except that here we give the allocation and release functions as separate arguments. Similar to manage, we need to use lift IO. Okay. Basically just says resource management is far from an easy task once you've considered how to hold on to resources for the least possible amount of time. And then apparently we're done with the principled monads. Like basically all the ones in the book that are given to us, and now we're going to start building custom monads. So next Tuesday, that will be what we do. We will start combining monads and see what happens, I guess. So the next chapter is called Functor Composition, and that's what we'll do next time. What time is it? Oh, nice. Almost perfect time. So let me commit this code, and I'll tell you a little bit about what's going on here. So if it wasn't clear, I was reading from this book, Book of Monads. You can get the book online, super easy to get. The typeface is beautiful, so there's the Amazon link. And also you can check out the code that I've written here. I put as much online as I can, so you can just go to my GitHub page and